Okay, this is part 2 of lesson 4.1/2, and this is looking at the rule of 3. The rule of 3 just means that there are 3 ways to represent a parabola. In fact, there's 3 ways to represent a line too. They're the same. You can have an equation. You can have a table. And from that table, you could take the points and make a graph. And this is a natural progression. If you want to try to get to a graph, you usually start with an equation, you make a table, and you use the points in the table to make a graph. This unit is actually going to be kind of all about skipping table. Being able to take an equation and make a graph without generating a table. First, we'll start by making tables, and then being able to look at a graph and come up with an equation. And if we can do that, we basically figured out quadratics. Easier said than done, though. We got about 3 units worth of quadratics to kind of figure all this stuff out. So let's start by making some tables from equations and then graphing them and looking at some similarities and differences. So to create a table of values, we're going to choose 5 values of x, where some are negative, some are positive, and 0 is pretty important because that would be our y-intercept. So, get my cursor out of the way, these are the values we're going to use. In fact, if you use these x values for graphing parabolas, generally you're going to do a pretty decent job, unless that parabola has been shifted left or right. But I didn't pick many of those, so we're going to use these ones. So let's fill in our tables here, -2, -1, 0, 1, and 2, and we're going to use those for all of our graphs. We're going to make 5 graphs here. So how do we come up with the y's? Well, an equation is just a rule. It's a rule on how you go from x and get a y. So what are we doing in this equation? Well, this equation says take your x's, square them, and that'll be your y. So off to the side here, I'm going to do a little bit of math. We're going to take our x, which is -2, and we're going to square it, making sure we square it in brackets. If we do that in a calculator, bracket -2 and squared, we get 4. So our first y value is going to be 4. And if we continue down the table, squaring all those x values, we would square -1, we'd get 1. If we square 0, we get 0. If we square 1, we get 1. And if we square 2, 2 squared is 4. And if you look at those y values, you'll notice something. 4, 1, 0, 1, 4. They're symmetrical around this 0. 1, 4, 1, 4. And if you remember, when we were looking at features, the point with which there was symmetry was that line that goes right through the vertex. So that number where it switches, that's going to be our vertex, coincidentally. Let's graph this and see what we've got. 0, 0. I'm going to use each of these boxes representing 1. 0, 0 is right here, 0, 0. And 1, 1 would be here. And 2, 1, 2, 3, 4 would be here. And -1, 1 would be here. And -2, 4 would be here. And I'm going to take these points and draw a smooth curve through them, and I'm going to extend it just a little bit. So I'm going to start at my vertex, I'm going to go up to the right, and I'm going to extend a little bit. And I'm going to take this, and I'm going to extend a little bit. The reason why we're only extending a little bit, not all the way through the graph, is, well, we could come up with more points and get a more accurate picture. But for now, since we don't really know what's going to happen next, I mean, we could figure it out, we could extend our table, but as we start graphing these parabolas early on, we won't extend it very far. Once we get more comfortable graphing parabolas, we can extend them a little bit further because we'll kind of know what's going to happen. But that's our first graph. Let's try C. I'm going to skip B for a second. Let's try C. If you look, the biggest difference in the equation is that instead of x squared, we have -x squared. So let's see what this graph is going to look like compared to our first graph. I should probably label this. I'm just going to put A here. Generally, I write the equation, but we're going to get 5 graphs on this graph, so we're not going to get too fancy here. Same x values, -2, -1, 0, 1, and 2. Why did I pick these? Well, I picked them because they are symmetrical, and I picked them because they're negative and positive. And in fact, if you pick them, I think you're set for making tables. So let's try this one. This time our y is going to be negative, and then we're going to take our x and square it. So careful, the x goes in a bracket and it's being squared, and then we're changing the sign to a negative. Actually, that's pretty nice because we already did all the work for taking those x's and squaring them. Now we just have to change all their signs. That just means we're going to use this table but with all negatives, right? Negative 2 squared is 4 times negative 1 would be negative 4. If we do negative 1 squared, we get 1 times by negative 1, we get negative 1. So yeah, 0 negative is the same as positive, so it's just still 0. And these ones are going to be negative 1 and negative 4. And if you don't believe me, let's do this one. Negative 2 squared. 2 squared is 4 times negative 1 is negative 4. The key is the negatives outside. If it was inside being squared, there'd be a bracket here. But there's not. So we put our negative 2, or whatever x value we're doing, and square it first, then change the sign. That's the difference in this equation. So if we graph this, well, 0, 0 is the same point as here, but 1, instead of going up to 1, we're going down to negative 1. And if we go over 2, we're actually going down 1, 2, 3, 4 to negative 4. And on this side, it's symmetrical. Negative 1, we went down to negative 1. And negative 2, we're going all the way down to negative 4. And basically, we end up with the same parabola, but upside down. And this goes back to the properties we were talking about. If the number in front of x squared is positive, we're going to open up because positive people smile. And if the number in front of the x squared is negative, negative 1, we're going to open down like a frown. And that's what we have here for our first two graphs. All right, let's go back to B. We've got negative 0.5 x squared plus 3. Hey, I think we might have just learned something. This graph starts with a negative in front of the x squared. This graph's going to open down. Let's see what we come up with. So negative 2, negative 1, 0, 1, and 2 for our x's. And we're going to plug those in. So let's see here. We got negative 0.5. We're going to take negative 2 and square it. And then we're going to add 3. This one's a little complicated. I'm going to put it in my calculator. So we've got negative 0.5, bracket, negative 2 is our x. We're going to square it, and then we're going to add 3. And we get 1. And now we're going to do the same thing for the rest of the x values. And what's kind of nice when you're making a table is if you have a calculator like this, you can just go change the x value in the equation. You don't have to type it in every time. So that's what I'm going to do. I'm going to change that to negative 1. And now we have the whole thing, but with negative 1. It equals, and we get 5 over 2, which is 2.5. Now I'm going to go change it to 0. And I get 3. I'm going to go change it to 1. And I get 5 over 2, which is 2.5 again. And then, hey, you might see a pattern here. 1, 2.5, 3, back to 2.5. Where are we going next? If it's symmetrical, 1. And if you don't believe me, you can check my math. So let's graph this one. Start at 0, 3. Start at the middle. 0 for x, 1, 2, 3 for y. And 1 is 2.5, so over to 1, up 1, 2.5. And 2 is 1, so over to 2, up to 1. Negative 1 gives us 2.5. Negative 1's here. 1, 2.5. And 2 is 1. Nope, missed that one. Negative 2 is 1. Negative 1, negative 2 for x, and 1 for y. And now we've got some points. Let's connect them. Extend just a little bit. Extend just a little bit. And as I promised, which way is that parabola open? It opens down like a frown. And it's because that number in front's negative. So I might be coming up with something here. This one was negative, and it opened down. This one was negative, and it opened down. This one was positive, and it opened up. What do we think D is going to do? 2x squared. Well, that one's positive as well. So we expect something to open up. Let's see if we get it. Negative 2, negative 1, 0, 1, 2. And to get our y's, we're going to take our x's, we're going to square them, and then we're going to multiply it by 2. Let's see if I can do these ones in my head. Negative 2 squared is 4 times 2 is 8. Negative 1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. And now I've got another table. Let's graph these points. I'm going to start with 0, 0 again. Hey, look at that right there. And 1, 2 would take me here, getting a little bunched up. And 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And on this side, negative 1, 2, and 2, all the way up to 8. So let's see if we can use these points. 0, 0 stayed the same. We're going to go up, extend just a little bit, and we're going to go up, and extend just a little bit, and that's graph D. Look at that graph. Opened up. So far the 2 positive ones opened up, the 2 negative ones opened down. Let's see a quadratic that has all 3 terms, because we haven't done one of those yet. All the other quadratics we did either had 1 or 2 terms. This one has all 3 terms. It's got an x squared term, it's got a linear term, and it's got a constant term at the end, 3. Let's first look at that x squared term. That x squared term is positive. So that means our graph is going to open up like we expect, because that x squared term is positive. Negative 2, negative 1, 0, 1, 2. This presents a whole new problem. We were just putting the x right here and squaring it in all the other ones, but now we've got another x. So what do? Well, our first x is negative 2. We definitely put it here and square it, and we also put it here. Everywhere there's an x, we take that x in our table and we plug it in. And now we have to do a little bit of math. Negative 2 squared is 4. 2 times 2 is negative 4, plus 3. 4 minus 4 is 0, plus 3 is 3. That first one is 3. Let's do one more to see if we got the hang of it. Y equals negative 1 squared plus 2 times negative 1 plus 3. Just using the equation. X squared plus 2 times x plus 3. X squared plus 2 times x plus 3. Our x is negative 1 for this one. Negative 1 squared is 1. 2 times negative 1 is negative 2 plus 3. 1 subtract 2 is negative 1 plus 3 is 2. Second y is 2. And I'm going to finish this one off in my head here. 0 squared is 0 plus 2 times 0 is 0 plus 3 is 3. If I plug 1 in, 1 squared is 1 plus 2 times 1 is 2. 1 plus 2 is 3 plus 3 is 6. And if I do 2, 2 squared is 4 plus 2 times 2 is 4. 4 and 4 is 8 plus 3 is 11. And if you want to check my math, go ahead. Hey, this one isn't the same as the other ones. All the other ones were symmetrical at that middle number, right? But this one, the middle number is 3. There's another 3 here. It looks like it's symmetrical here. This one's not symmetrical in the same way. There's no 11, 6, 3, 2, 3, maybe 6, 11 if we were following the pattern. So that means that our table negative 3 would be 6 and negative 4 would be 11. That would be fully symmetrical. Let's graph the points we have and see where we're at. Negative 2, 3. 1, 2, 1, 2, 3. And negative 1, 2. Negative 1, 2. and 0. Sorry, did I make a mistake? Nope. 0, 3 right here, and 1 is 6. 3, 4, 5, 6. And the other one's 11, which is off the graph. So we've got something that looks like this. And the nice thing about this is this doesn't look like a full parabola. We've got here to here to here, but since we know it's symmetrical, this point, there should be another point right here. And we can complete the picture because we can use the property of symmetry. We see, oh, this should be E. I don't know why it wasn't labeled E. But we can use symmetry to come up with the other point. So if you make a table and you don't end up with all the necessary points to make it symmetrical, you can add points because you know that a parabola is going to be symmetrical. In fact, if you wanted to check -3 for x, you do get 6, which is that extra point I added. All right, what are some things we noticed? Well, all the parabolas were symmetrical. That's one thing we noticed. And we noticed that that ax squared term, that number in front of the x squared, tells you which way it's going to open. If a is positive, we get a graph that looks like this. It opens up. And if a is negative, our graph opens down. There's one more thing I wanted you to notice. I don't know if you caught it or not. I didn't talk about it at all. But let's see. Three of the parabolas have the same vertex. 1, 2, and 3. They all have 0, 0. And the three that have the same vertex 0, 0 are A, C, and D. And two of the parabolas have a vertex that's right here. Sorry, not a vertex. What was I talking about? Not a vertex, y-intercept, sorry. Three of the parabolas have a y-intercept that's right here. The vertex is actually at the y-intercept, 0. Two of the parabolas have a y-intercept of 3. The ones that have 0 are A, C, and D, 0. The ones that have 3 are B and E. If you look at the equations, the ones that have 3 have a 3 as the constant term. And the ones that have 0 don't have a constant term. And that's because the constant term tells you the y-intercept. Constant term is the y-intercept. The constant term is that c term. And that's if we're talking about the ax squared plus bx plus c. That c is the y-intercept. And that a tells us our direction of opening. So just from looking at the equation, we should be able to tell the direction of opening and the y-intercept. That bx term doesn't actually tell us any features of the graph. What differences did we find? Well, I guess the y-intercepts were different. We should have put that down there. And I suppose the similarities were really just that they were all symmetrical. Some of them had the same, some A being positive, so they opened up, but some of them were negative, so that's technically a difference. I kind of answered both questions at once. That was a really poor explanation of that. What's important here? Three things. All parabolas are symmetrical. The A in front of the x squared tells you which way it opens. And the C, the number at the end, tells you the y-intercept. You also need to be able to make a table from an equation and then graph the points in the table. And we should always use these x values. If we end up with a parabola that's not symmetrical, we can use the other side of the parabola to make it symmetrical. And that's it for the rule of three. A lot of information all at once. We're going to do a lot more graphing. So don't worry if you missed some important aspects. The big thing is that you can take an equation, make a table, and turn it into a graph. The similarities, differences stuff, we're going to continue to explore for about 3 more lessons. So don't worry if that kind of went over the head a little bit. But that's it for part 2. I'll see you in part 3.